So now in this section we're going to move on from just operations with radicals, adding, subtracting, multiplying, dividing. We're actually going to solve equations with them. Solving equations means finding what value of x makes this equation true, but there is one complication involved with radicals that makes some of the answers we find extraneous or false. There's no way to avoid it. It's a consequence of the process that we use. We just need to, at the end, double check that the answer is correct. I'll show you what that looks like as we go. First things first, we do need to make sure that the root is isolated on its own side of the equation. You can see in this one we have 5 plus root 2x minus 1. We need to move the 5, so we'll subtract 5 from both sides. And we get square root of 2x minus 1 equals 7. Once we get the root isolated, simple process, to the opposite of a square root is an exponent of 2, so we'll square both sides. That cancels the square root, and we're left with 2x minus 1 equals 7 squared, which is 49. And at this point, this becomes a simple solving equation, things you would have seen in grade 9 and the like. We'll have to add 1 to both sides, so 2x equals 50. Divide both sides by 2, we get x equals 25. Now what we need to do once we get to this point is we need to actually check and make sure that 25 does satisfy the equation. To do that, we take the original equation, we substitute 25 in for x, and we check whether or not the equation works out. That's what the question mark above the equal sign means. You just need to work out, make sure the left side and the right side work out to the same thing. So, step by step, 2 times 25 would give us 50. (50 minus 1 would give us 49. Square root of 49 would give us 7. And at this point we can see that the left side will work out to 12, which is the same as the right side. So 25 checks out, and it's a perfectly valid answer.